Assalamualaikum warahmatullahi wabarakatuh. Today, our group member will present the assignments which the topic is speed control of induction motor. My name is Shazwan Hakim bin Mashaha and I would like to present about the overview of induction motor and the top speed characteristic curve. An induction motor or asynchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor can therefore be made without electrical connections to the rotor. An induction motor's rotor can be either wound type or squirrel cage type. Three-phase squirrel cage induction motors are widely used as industrial drive because they are self-starting, reliable, and economical. Single-phase induction motors are used extensively for smaller loads, such as household appliances like fans. Although traditionally used in fixed-speed service, induction motors are increasingly being used with variable frequency drive in variable speed service. The variable frequency drives offer especially important energy savings opportunities for existing and prospective induction motors in variable torque centrifugal fan, pump, and compressor load applications. Squirrel cage induction motors are very widely used in both fixed speed and variable frequency drive applications. Torque speed characteristic is the curve plot between the torque and the speed of the induction motor. The induction motor torque speed characteristic give information on the dependence of induced mechanical torque on mechanical speed. Sometimes this characteristic is called torque slip characteristic, where slip is defined as speed relative to synchronous speed expressed as a fraction of synchronous speed. Typical torque speed curve of a squirrel cage induction motor uh, provide information about the operation of induction motor. The induced torque of the motor is zero at synchronous speed. The curve is nearly linear in normal operating conditions, which are between pull-out speed and synchronous speed. Maximum possible torque the machine can induce is called the pull-out torque or the breakdown torque, and it limits the short time overload capability of the motor. It is usually 2 or 3 times the rate full load torque of the motor. The starting torque of the motor is slightly larger than its full load torque, so this motor will start carrying any load that it can supply at full power. The torque speed characteristic is required in order to predict behavior of induction machines in electrical motor drive. It should be measured as accurately as possible, while the selection of which method to apply depends on the characteristics of both the machine and the testing facilities. The maximum torque is independent of the rotor resistance, but the exact location of the maximum torque Tmax is depending on it. Greater the value of the R2, the greater the value of the slip at which maximum torque occurs. As the rotor resistance increases, the pull-out speed of the motor decreases. In this condition, the maximum torque remains constant.
Speed control of induction motor. There are 6 types of speed control of induction motor. Firstly, frequency control, controlling supply voltage, changing of number of poles, adding external resistance on the rotor side, cascade control method, and inject EMF in rotor circuit. Firstly, frequency control. If we look at the equation above, F equal to frequency of the supply side of the motor, P equal to number of stator poles in the motor, and S equal to synchronous speed of the motor. Number of poles in the stator side and the frequency of the supply side will affect the synchronous speed of an induction motor. In this case, by manipulating the frequency of the supply side of the motor, speed will be changing as well. But this method is quite harder than other motor control method. Secondly, controlling supply voltage. If you look at the first equation is the torque of the three-phase induction motor, and the second equation is the simplified equation. So it can be concluded that EMF is directly proportional to the voltage supplied. In conclusion, speed and torque of the three-phase induction motor can be controlled by manipulating the supply voltage. The third one is changing of number of poles. Changing the number of poles can be classed to two methods. Firstly, multiple stator winding method, and secondly, pole amplitude modulation. Multiple stator winding method use two different windings in the stator. These two windings are placed from each other and wound for separate poles. Speed control is possible because of the switching arrangement. Supply is only given to one winding only. Smooth speed control seems to be the problem of this method. Another disadvantage is this method is quite expensive, and moreover, it is less efficient. Finally, this method can only be utilized to squirrel cage motor only. The fourth one is adding external resistance on the rotor side. This method is achieved by adding rheostat. In doing so, an external resistance increases on the rotor side, causing the voltage to drop. Torque produced for the phase induction motor voltage is parallel to torque. Decreasing the voltage value will decrease the torque, but torque must remain the same if applied the same load, and it is only possible by slip increase. Motor will reduce speed if slip increase. The fifth method is cascade control method. It is called a cascade control method because two three-phase induction motors are connected on the same shaft. First motor is the main motor and the second one is auxiliary motor. Power is given to the main motor whilst driving the auxiliary motor. Slip frequency from the slip ring is used to drive the auxiliary motor. Finally, the injection EMF in rotor circuit, which is the last motor control method. While frequency remains the same as slip frequency, this method adds an external voltage to the rotor circuit to manipulate the speed control of induction motor achieved by injecting EMF in an opposite phase of the rotor, simultaneously increasing the resistance of the motor. For the study case of international speed control method, we choose speed control using VFD, which is variable frequency drive. VFD consists of three major parts. Firstly, the rectifier. This part consists of either diodes or transistors. The diodes are configured in bridge connection. When AC supply passing through, there are only positive peaks that remains as an output. By doing this, the coming voltage frequency will be double, but the sine waves are still in the ripple state which needed to be flattened out. This is where the DC bus plays its part. The ripple wave from the rectifier later then passes through the filter, which is capacitor, which later then smoothen out the wave into DC output. The inverter converts the wave back from DC to AC, but not before the sine wave went through PWM, which is pulse width modulation. Microcontrollers are used to perform PWM, which can be done by changing the frequency range of the inverter switching. The supply will be turned on and off by different frequency to achieve the desired output. Firstly, PWM are simulated using Proteus software before making the real one. As the PWM wave passes through the inverter, which consists of IGBT, or known as insulated gate bipolar junction transistor. The reason why IGBT is being used is because of its high current and voltage rating, and very fast switching speed. IGBT connected in H-type configuration, while two PWM are being supplied to it. The first PWM is the normal one, and the second one is complement PWM. The reason behind this is to excite the first and the fourth IGBT in order to create rising clockwise waveform from the complement, while the complement PWM are to create rising anti-clockwise waveform. Finally, benefits of using VFD. There are 7 benefits of using VFD. Firstly, energy efficient, simple installation, improved power factor, reduction in kVA, high efficiency of motor, lower thermal, finally mechanical losses.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Shafiq bin Yusri from group of speed control induction motor. So today I want to present about my part, which is case study in Malaysia. Is about wound rotor induction motor. So the concept or the reason why I choose a one round motor induction motor is to compare or to retrofitting smaller value horsepower, uh, which is 500 below horsepower or 500 less horsepower, vintage on motor with modern low voltage induction motor and variable frequency drive, which is VFD, functional equivalent. Okay, we continue and go through to the what is the one round motor. Okay, the one round motor is an induction motor where the rotor circuit is terminated in slip rings to which external impedance can be connected. So you can see on the picture I put at the slide that is the typical one round motor for use in the trolley motion of wood yard portal crane. Okay, one round motor is primarily used to start a high initial load or a load that requires a very high starting torque across the motor's full high speed range. So by applying the resistor to the motor slip rings, the motor is able to produce very high torque, which is 200% to 280% at a relative low current, 175% from 0 to full speed. Relatively low locked rotor amperes are why these motors are sometimes employed in application on weak power grids. Okay, in order to control torque production in the one round motor, resistor banks are switched in and out by means of high current electrical contactor. So you can see at the figure 2 I put on the slide, that is the typical one round motor control system schematic diagram. Okay, so these resistors are called secondary resistors and are sized on secondary rotor amperes and the application stock requirements. So in general, if the application operate below 50% speed for high percentage of its operational cycle, it may be a good candidate for modernizing to a VFD as a way to save energy. If the motor is operated at reduced speeds for most of its duty cycle, relatively more energy is being absorbed in the resistor banks for torque production. Depending on the application horsepower and duty cycle, the energy saving can be in the hundreds of kilowatts per hours. So while the resistor banks are typically not prone to failure, the contactor which switch resistor banks in and out of service for speed control of the one round motor typically replace or service on a yearly basis or more frequently depending on usage. Generally speaking, what is to be accomplished by the secondary resistor controller is shown in the aforementioned chart, which is representation of the speed to torque characteristic of a one round motor that you can see on figure 3. That is the general representation of torque production in a one round motor. Okay, the sawtooth like waveform is the torque profile produced by the shorting of resistor banks by the controller as the load is accelerated from zero speed on the far right of the curve far right of the curve to the leftmost portion, so which is the slip speed of the motor. Okay, by setting upper and lower limits when the resistor banks are shorted out, a rope constant torque profile can be produced. So for many years, this was one method that allowed an induction motor to produce the overload torque from 0 to slip speed. Okay, retrofitting one-round motor-based control system to a VFD based system can provide precise speed and torque control, and can also eliminate a list of potential issues. So there is many list of potential issues. So for the first is susceptibility of slip ring brush to contamination. Second, slip ring brush maintenance. Third, slip ring brush ringing, burning and melting. Fourth, resistor contactor bank pitting and maintenance. And the last, energy losses is in the resistor bank during low speed of operation. That is the list of potential issues. Okay, lastly, newer active front end VFD system can regulate power factor close to unity, and regenerate energy can be used by other drivers connected to the common power distribution network, thus providing energy savings, power factor improvement and better speed control. The conclusion, we know that induction motor can use for single phase, two phase, three phase. So the for three phase induction motor is the motors most frequently encountered in the industry. Okay, they are simple, low price and easy to maintain. Moreover, such machines are called induction machine because the rotor voltage, that means which produce the rotor current and the rotor magnetic field, is induced in the rotor windings rather than being physically connected by wires. Also, we know as induction motor is a constant speed motor and robust in construction, and need less maintenance and can operate in hazardous location. Next, induction motor have two major parts, which is stator and rotor. Can be tested on no load test and blocked rotor test. And lastly, the speed of induction motor can be controlled by pole changing method, frequency control and line voltage control. Alright, that's all from me. Thank you.